welcome you all to Mass Expert Video Tutorials. We are still journeying through statistics 2, and in the previous video we look at how to test the difference between two means. But if you can check it well, the previous video was dealing with when we have a large independent sample. Large independent sample. Here too, we are going to look at small independent sample. So you can see that in both cases, the samples, they are all independent. But we have the case where the sample size is large and the case where the sample size is small. So they are not the same, please. They are not the same. So that's what we are going to look at it now. So watch out for it and you will have it. Okay. So now let's see the requirement. The requirement is that the sample must be randomly selected. The sample must be randomly selected. That one here is constant. Alright. 2. The samples must be independent. That one too is constant in both cases. The sample must be independent. Each population must have a normal distribution. That one too is there. But the last one, n should be less than 30. That is the key point here. And that is the concept I want to give you. This is representing the small sample. Because here we have the n, which is the sample size, being less than 30. In the previous video, that is when the sample size is greater than 30. And that is when we use Z score or the Z test. Please, don't forget about all these things. Because even from the beginning of all that we are doing, whether we are using the Z test or the T test, or whether the Z distribution or the T distribution, anytime your sample size is less than 30, that is when we use the T test. So looking at this, now the sample size is going to be less than 30, yes. So even though it is going to be independent, but the sample size will be less than 30. That means that we are using T distribution. So because of that, you have to make your T distribution table available with you. Alright, so we will be using it and you know how to use it already. Okay. Alright, so another requirement is that, let me add is that we are going to always base on the traditional method. In fact, of all the two means, even the previous video, we were basing it on the traditional method. Don't go by the p-value method. Alright, good. Now let's see the standardized test statistics. The standardized test statistics. Now, this formula, I always don't want you to chew it because it's the same as the one we had when we were doing the confidence interval, and that one was S bar. Or when we were dealing with one mean, that would be S bar mu over, then we have the S here over the square root of n. Is that also? But here we are dealing with two means. So if you know this, don't choose this. Two means that then this will be 1, 2. So you subtract the second one from it. This one to be 1, 2. So you subtract the second one from it. So that's why here we are having it to be 2. The sample sample standard deviation. The sample standard deviation 2 is going to be 2, based on the 8 point of estimate. Alright, so that is that. But please, here we are going to deal with these two cases. There are some cases that the sample variance or the population standard deviation or the sample standard deviation that will be given to you. It's not always that it's going to be the same. It's not always that it's going to be. There are some cases that it will be the same, and there are some cases that it will not be the same. So, and if it's the same, the degree of freedom differ. And if it's not the same, the degree of freedom to differ. So let me introduce that to you and you will have it. Alright, so this is what I'm talking of. When the variances are equal, I mean this. We want to determine what will be coming here, alright? Because it's not about you achieving this, it's about you knowing what is the inputs about, alright? So when the variances are equal, the variances, it can be population standard deviation or the sample standard deviation, alright? It's still the same thing, whether this one or that one, alright? So when the variances are equal, it is called pooled estimate of the standard deviation. Pooled estimate of the standard deviation. And when they are the same, you can see something. See, when they are the same, we know that when they are the same, there's going to be a square here, right? And there's going to be a square here. So that means that this one will not come. This is what you know already. So if they are the same, it means we can factor this out. And when you factor this out, here will be left with 1, here will be left with 1. And that square root, it will be something like this, all square. So that one will cancel this one. So it means that you can pull out the standard deviation. That is why it is called pooled estimate of the standard deviation. Alright, so that is that for that. So when the variances are equal, you will use this here. Instead of writing this, you will write this one rather. This, please understand it. This is when the variances are what? Equal. Alright. And the degree of freedom you are going to use is also this. It's n1 plus the n2 minus what? 2. And that is what is going to what? Be. Alright. So now, let's look at when variances are not equal. When variances are not what? Equal. Alright, so let's look at that 1, 2. So when they are not equal, this one here is going to be equal to this. So now, see now, it's not equal, right? You know the S is representing the sample standard deviation. I share whether sample standard deviation or population standard deviation. It doesn't matter anything. From the question, if you hear sample standard deviation, represent it by S. If you hear population standard deviation, represent it by what? By the sigma. Alright. So when variances are not equal, that means that you cannot pull out, you cannot factor the sample size the variance out. Like what we have factored out here, you can't pull this one out like that. So you maintain it like this. Then you use the degree of freedom being equal to n1 minus n2 and n2 minus of n1. So here you are going to get 2 degree of what? Freedom. Instead of here you are going to get 1. So don't forget it, don't forget 8. Know this and know how to relate this to 8. Thank you. I'll be back. Alright, so maybe you don't know what is going on here. This is what is going to help you, okay? Using the 2 sample t-text. Why is it t-text? Because our n will be less than what? Or our sample size will be less than what? 30. For the difference between the 2 steps. The first one is that it's related to what we have done already. You will state the what? The null hypothesis and the alternate what? Hypothesis. Then you identify your alpha. Thirdly, you determine the degrees of what? Freedom. And you know the degrees of freedom here depend in 2 ways. Be careful. In the t-test is 2 ways. In the z-test is 1 way. The z-test is when n is greater than what? 30 is 1 way. But in t-test, when n is less than 30 is 2 ways. That is when you have your variance to be the same or not what? The same. Alright, let's continue. 4. Determine the critical values. Determine the critical values. And you know the critical value, alright. 5. Determine the rejection rating. So when you determine your critical value and you have your normal curve, then you can determine your rejection rating using the what? The standardized test statistics. That is why it says find the standardized test statistics, because that's what you're going to use. Then you interpret the decision in the context of the original claim. Alright, so let's come back to our first question and this small independent sample. Small independent sample, and you will have it. Alright, it's not difficult. Okay, good. So let me conclude the question. So we have the sample statistics for states, mathematics states. Test 4. Alright, so we have teacher 1, we have teacher 2, we have, I hope you know what this means. What does 8 mean? Because it's not the same, it's not the person that, for instance, after this I'll give you one to go and try. It's not all the same that they will bring it out for you. They can fuse it inside the person and you should be able to identify it. This is the what? The point estimate for the what? For the mean. So if it was to be inside of this question, you hear that the means of the state mathematics test score are this and this. So when you hear the mean, that is that. Okay? Alright. And that is 473 459. Alright. And we have S1, that is what? Please, this is not this. Okay? This is the population standard deviation. And this is the sample standard deviation. So in the question, you hear something like, and the sample standard deviation of the state mathematics test score are this and that. I always learn. Alright, so that should also tell you something. 39.7, 24.5. N1 is 8, N2 is 18. Good. So now, when you have a question like this, before we come to everything, you have to know what you are dealing with. Alright, it's very, very important, and it's one key here. You have to know what you are dealing with. So, what to make you know what you are dealing with? First, you have to check if it's dealing with two means. And if it's independent, in fact, for the independent, you will see it because we have the independent and what? Dependent. The dependent, a table will be given to you. You will be given a table. Yeah, so for that one, you will see it. After this, you will go there. So let me talk about the two means and what the means is about. The result of a state mathematics test for random samples of students. So if I'm to bring this one here, it will be random sample of 8 and 18 students respectively. How will you feel the person will be? Alright. Taught by two different teachers. They were taught by two different what? Teachers. So see, different teachers. So that should tell you that this is independent what? Question. It's an independent. And they were taught by two different teachers at the same school, are shown at the left. So what does it mean? Are shown at the left is now that's what we have here. Okay, so don't worry about the left. That's what it is. We have here. So two different teachers is telling you something about the mean, because you have to know the mean 1 and the mean 2. So here you can see that the mean 1 will be teacher 1. Or you can see that then the mean 2 will be teacher 2. That was clear. Alright. So let's continue to see the claim. Alright. If not, we can go by the first step, that is stating the now and the alternate address. Can you conclude that there is a difference in the means? And what are the means? Teacher 1 and teacher 2. So can you conclude that there is difference in the means mathematics test score for the students of the two teachers? Use alpha level of 0.10. Assume the population are normally distributed and the population variances are not equal. In fact, not all the questions that it will tell you that the population variance are not what? Equal. Okay? Alright. So, this one's supposed to be the sample. In fact, whether population or the sample or whatever, you can use whether this or the other one. It's just that you have to deal with it. You have to know that you're doing the right thing. Alright, good. Because the formulas are the same. So you let me change it to sample. But you can maintain it to be the distribution. The sample variance, since I'm using the S here. Alright, so let's assume it wasn't stated here. If it wasn't stated, you know that the sample variance or the population variance, you can see it here that they are not the same. So if they are not the same, you have to know the formula to go by and the degree of freedom to go by. Hope it's clear. Alright. Good. So that is that. So now let's see the claim. The claim is that, can you conclude that there is a difference? Can you conclude that there is what? A difference. So we have step 1. The null hypothesis, that one that we know is always equal to the mean 2. It will always equal to. So this one is difference, right? So the alternate will be mean 1 is not equal to what? Mean 2. So this is the claim. This is where the claim is. This is where the claim is. Okay. We are done with that one. So the next step is what? The next step is that we have to identify our alpha. So what is the alpha here? Alpha is 0.10. Okay. The next step is that we have to find our degree of what? Freedom. Is that also good? And our degree of freedom here, which formula are we using? We have the case that the variance are the same, and a case where the variance are not what? The same. So in this case, alright, so in this case, we can see that the sample variance and the population variance are not what? The same. So if they are not the same, that means that our degree of freedom is going to be n1 minus 1, n2 minus what? n2 minus what? 1. Alright, so with this, let's move on. So we know that our n1 is what? 8. And our n2 is what? 18. Alright. Alright, so we know that here, the sample variance or the population variance are not the same. So if they are not the same, that means that we have n1 minus 1 and n2 minus what? 1. So we are going to identify our n1, which is 8, our n2, which is what? 18. Good. And what we are doing is that we know that the sample size is less than what? 30. So if the sample size is less than 30, that means that we are using t-test. Is that also? Alright. But the degree of freedom that we are going to get, we are going to get 2 degrees of freedom. But it doesn't mean that we use the 2 degrees of freedom in the readings, because the reading of this table show only 1 degree of what? Freedom. So let's see what we are going to do. You will love it. Alright, so now the n1 is 8 minus 1, n2 is 18 minus 1. So this will give 7, and this will give what? 17. But we know that the sample size is less than what? 30. That means that simply we are dealing with what? Small sample size. So if you are dealing with small sample size, that means that you will pick small degree of what? Freedom. Please, don't get me confused here. We have n1 minus n1. If, let's say, the sample size, the population standard deviation is the same. If the population standard deviation is the same, that means that the degree of freedom will be n1 plus n2 minus 2. Is that also? This one will just give you only 1 degree of freedom. But this is when the sum or population variance are the same. Not that the sample size are the same, but the population variance are what? The same. This will give you only 1 degree of freedom. I want to emphasize this on it all. Alright. But this case, what we are doing here, the variance are not the same. Or not what? Equal. That means that the degree of freedom you are going to use is n1 minus n2. Sorry, n1 minus 1. And another degree of freedom, which is n2 minus 1. But after getting the results, we are dealing with small sample. So check the smaller degree of freedom and use, that's all. So therefore, that means that the degree of freedom that we are using is what? 7. Please, don't forget it. Alright. So what is the next stage? The next step is that is the 4th step, right? Good. That is to determine the critical what? Value. To determine the critical what? Value. And here I have told you already that we are using the what? What are we using? Traditional method. Alright. So the critical value, that we know that we are using the t-test. The t-test. Alright, so here we are going to draw our normal distribution there. We read from our table. Alright, so all that we are going to do here is that we are going to draw our normal distribution. Beautiful. So that's the 4th stage. You draw your normal distribution, right? Now, here, you know that the alternate hypothesis is what we use.